Alright, let's determine the point at which the slope of the tangent to the parabola is 0, and the equation of the parabola is y is equal to 6x squared minus 3x plus 4. So let's find the slope of the tangent at any point on this parabola. So let's find the derivative function. So the derivative function f prime of x is equal to the rate of change of y with respect to x. So I'm using Lagrange's notation, and then I'm also utilizing Leibniz's notation. They relatively mean the same thing. And then I'm going to do a derivative of each of these. Okay, so I'm using the derivative modifier, 6x squared minus 3 times the derivative of x plus the derivative of 4. So you can see that I'm using a combination of the sum and difference rule. And then you get like 12x minus 3, and the derivative of constant is 0. So this is basically your slope of the tangent function at any point. Alright? Now you want to figure out when the slope is 0, right? So you're going to let f prime of x equals 0, so 12x minus 3 is equal to 0. If I want to solve for x, I'm going to move the 3 to the other side, and I'm going to divide by 12 to both sides to just solve for 1x. So x is equal to 3 over 12 is the same as 1 over 4. Right? You can divide this by 3 to find that out. Now that you have x is equal to 1/4, you want to find the point. Well, we know that we have the x value of the point. To find the y value of the point, you need to plug it into your original function. So I'm going to do f of 1/4 into my original function. F of x is equal to 6x squared minus 3x plus 4. F of 1/4 here is 6 times 1/4 squared minus 3 times 1/4 plus 4. I'm going to clean this guy up. So this is 6 times 1/4 squared is 1 over 16 minus 3 over 4 plus 4, which is 6 over 16 minus 3 over 4 plus 4 over 1. And I'm going to use the lowest common denominator, that's 16. So this is 6 over 16. I'm going to multiply this guy by 4, so minus 12 over 16 plus, multiply this by 16, 64 over 16, which is negative 6 plus 64 over 16. And that kind of looks like negative, well, it's positive 58 over 16. Okay, you can simplify this, right? If you divide this by 2 and this guy by 2, this looks like 29 over 8. Okay, so therefore the point is 1 over 4 and 29 over 8. Okay, and that's basically where the slope of the tangent to the parabola is 0, right? And usually when the slope of the tangent is 0, we usually mean a minimum or maximum point, so an extrema basically, because at these points, right, the slope of the tangent is equal to 0. So it's a great way to look for minimum and maximum points.